Welcome to lesson 11, quicksort. This algorithm will split the array into chunks. Each chunk is going to have its own pivot. A pivot could be the median value or it could be the last element in the chunk. And then this pivot is going to be compared to the remaining items of the chunk and so on. Example. As the array contains 12 elements, the median will be sitting at index 0 plus 11 divided by 2, so index 5, because we don't care of the fraction. Compare the pivot to the left edge. The pivot will move to the beginning of the array as 12 is bigger than 8. Compare the first element to the last one. Nothing to do. Compare the median to the right. They will swap. Move the pivot to the right side, just before the last element. Try to find a bigger value than the pivot on its left, but there is none. Try to find a smaller value than the pivot on its right, but there is none. The pivot is now bigger than the elements on the left, while it's smaller than the elements on the right. Two partitions are now created, separated by the pivot. Each one should calculate its own pivot. The right one will not need one, as it contains a single item only. And this is new pivot for the left partition. Swap the element on the left and the pivot as they are not sorted. Check whether the left and the right edges are sorted. They will swap. Check whether the median and right element are sorted. They will swap. Move the pivot to the right. Check whether the elements on the left of the pivot are sorted. The element 7 was found. Elements on the right of the pivot are sorted. Swap them as they are not in order. Keep swapping. Two more partitions are created. The one on the left will be sorted now. Compare the edges again, and so on. Let's build for the bug. Let's run it. Okay, unsorted and sorted. Let's have a look at the source code. So stop at line 1 to 1. Partition size, which is going to be 12, so it means that we are considering the whole array. If partition size is less than or equal than 3, then you just need a simple swap, but that's not the case. Now, sort the pivot, the first and the last element of this chunk, and you return the median. Calculate the center, which is going to be left is 0, 11. We don't have the decimal part because we need integer, as arrays indexes are always integer, so we don't need 5.5. And now swap pivot if it's smaller than item on its left. So if I do this, and then I print this other one, I know that 12 is bigger than 8, so they will swap. In fact, 12 and 8. And in fact, they're swapping. Okay, they just swapped. Now compare left and right side. Now print this one over here and this one. Do they need to swap? No. So step, compare pivot and right side. So you do print 12 and this one. Do they need to swap? Well, yes, because you have that 12 is here and 11 is here, right? So they need to swap. Swap. Okay, so let's do a little bit of recap. The 8 is not in the middle of the array anymore. 12 is the last one, when 11 used to be the last element at the really beginning. So quite a few things have changed. Now move the pivot to the right side, because the pivot always have to be on the right side, at least in this implementation. So just remember this. We're going to be swapping again. Okay, so if I do, the pivot is here now. It used to be right in the middle, right? So we like to keep the pivot right before the last one. Okay, now we return the array passing, well, actually we're returning the position of the pivot. Yep. And we're here now. So the next is going to be here. So right here, create more partition. Okay. Now we need to find any element on the left of the pivot that is bigger than the pivot itself. But looking at the array, we know that if this is the pivot, none of this element is actually bigger than the pivot itself. So now we need to find an element on the right of the pivot which is smaller than the pivot, but the only element which is the left of the pivot is 12, which is bigger than 11. It's not smaller, so we have nothing to do here. Now check whether cycle walk out of the partition, because we have two indexes here. Restore the pivot. And return left bookmark. Now, if I do, now the pivot is still here, and those elements exactly where they were before. Step. Okay, now sort the left partition we just created, right? So step. Partition size now is going to be $10, because right? So 9 plus 0 plus 1. We are still much bigger than 3. Now sort the pivot, the first and the last element of the chunk. Calculate the center again. We know that four, so you know that this is going to be the next pivot, right? Because eventually this is the current chunk, because this used to be the previous pivot. That's the other chunk which is not going to be sorted anymore because it's already sorted. So we are working now on this chunk over here, right? So we need to swap if the pivot is smaller than the item on its left. So let's see what in here. And then let's see what's in here. So if 8 is bigger than 6, which is the case, we need to swap. And in fact, they are swapping. Down container. So 6 that used to be around here, let's see, 6, yes, used to be here, and now is at the beginning of the array. They just swapped. And so on. I think you have enough information now to continue by yourself. I really hope you've enjoyed my class, and thank you very much.